Hi guys and welcome back to my channel. This is the final episode of the Carbon Cycle and Energy Security Revision Unit over here on my channel. Today we're going to be looking at responding to climate change, so do stick around, subscribe down below. Go check out the rest of the playlist if you've missed any of it. I'll try and remember to link it up here, but if I do forget, it's just on my channel. There are loads of different revision series over there. So yeah, I really do hope you enjoy, but without further ado, let's get into the final episode of this series. Future emissions. For 3 decades, climate scientists have warned that increasingly rapid melting of the Arctic ice cap could cause uncontrollable global climate change. The warning signs are getting louder, said Marcus Carlson at the Stockholm Environmental Institute. The problem is that much of what could happen is clouded by uncertainty. As energy consumption rises, global greenhouse gas emissions are expected to continue to increase. However, what is not certain is how much they will increase, or what the greatest increases will be. Atmospheric concentration levels. Greenhouse gas concentrations are likely to continue to increase, as emerging economies such as India industrialise further. The problem is that greenhouse gases remain in the atmosphere for a long time. Even if global emissions were to stabilise or decrease, the surface air temperatures would continue to warm because greenhouse gases would still be added to the atmosphere faster than carbon sinks could reabsorb them. Because of the difficulties involved in projecting future emission levels and the capacity of carbon sinks to absorb them, climate scientists use a range of scenarios to show projected greenhouse gas concentrations. The highest emission pathway assumes that emissions will continue to rise throughout the 21st century as prosperity and demand rise. The lowest emission pathways assume that emissions will peak by 2020 and then decline as low emission technologies develop further. Climate warming. Climate models predict that surface temperatures will continue to rise, with increases between 2000 and 2100 in the range of 2 to 6 degrees. Temperatures are expected to warm more rapidly over the northern hemisphere, which has more land than ocean, and some regions, such as the Arctic, will see larger increases than the global average. Why is future climate change so uncertain? A range of physical and human factors can make future predictions about climate change uncertain. Physical factors. Oceans and forests act as carbon sinks and store heat. Oceans take decades to respond to changes in greenhouse gas concentrations. Their response to higher levels of greenhouse gases and higher temperature levels will continue to affect global climate for possibly hundreds of years. Human factors also play a role in forests. Last week's episode, we talked about that. Although the amount of forested land is increasing in high-income countries, the overall global total is falling, particularly in the tropics. Human factors. Economic growth. After the financial crisis of 2008, there was a worry that rising CO2 emissions would follow the recovery of global GDP. However, after rising by 4% per year since 2000, the rate of emissions growth fell to 1% by 2012 to 2013 and 0.5% by 2014. Nevertheless, total carbon emissions still reached a new record. Energy sources. Energy consumption grew 2% between 2008 and 2014. However, renewable sources made up 2/3 of the increase in electricity production in 2015. Population change. Increasing affluence in emerging economies means a potential extra billion consumers by 2050, with spending power equal to the USA. Changing diets and increased mobility means more emissions. Feedback mechanisms. One of the uncertainties about climate change concerns feedback mechanisms, such as carbon release from peatlands and permafrost, and tipping points, including forest dieback and alterations in the thermaline circulation. Feedback in climate systems can either dampen or amplify responses that affect global climate. Negative feedback dampens the original process, and positive feedback amplifies it. Peatlands. Most of the world's wetlands are peat. Peat is the accumulation of partly decayed vegetation and stores large amounts of carbon because of the low rate of carbon breakdown, decomposition in cold waterlogged soils. Warming causes peats to dry out as water tables fall, as well as increasing the rates of decomposition. A warming of 4 degrees causes 40% loss of soil organic carbon from shallow peat and 86% from the deep peat. Peatlands tend to emit carbon in the form of methane, increasing the concentration of greenhouse gases. Permafrost. When permafrost melts, it releases trapped carbon into the atmosphere as CO2 and methane, increasing greenhouse gas concentrations and leading to increased temperatures to melting. Tipping points. A climate tipping point is a critical threshold. At a particular moment in time, a small change in the global system can transform a relatively stable system into a different state. 2 particular phenomena are capable of creating tipping points: forests dieback and changes in the thermaline circulation. Forests dieback. Rainfall in the Amazon basin is largely recycled from moisture within the forest. If the rainforest is subject to drought, trees die back. A tipping point could be reached, where the level of dieback eventually stops the recycling of moisture within the rainforest, resulting in further dieback. In the boreal forest ecosystem, stretching across Europe and Siberia, hot, dry summers lead to water stress and cause trees to die. A tipping point could be reached where the trees will no longer absorb enough CO2 from the atmosphere, leading to increased levels of greenhouse gases. Changes to the thermaline circulation. Cold, deep water in the North Atlantic forms part of the thermaline circulation. To keep the conveyor belt of warm water heading from the tropics towards Britain, heavy, salty water must sink in the north. However, the melting of the northern ice sheets releases significant quantities of fresh water into the ocean, which is lighter and less salty, thus blocking and slowing the conveyor belt. As ice sheets melt, the ocean circulation is susceptible to a critical tipping point. Facing the future. Even if greenhouse gas emissions were to stabilise or perhaps fall, the planet would continue to warm. It will be important to assess consequent changes, whilst trying to prevent them from worsening. The IPCC outlined 2 approaches for the future. Adaptation strategies. Adopt new ways of doing things in order to live with the likely outcomes of climate change. And mitigation strategies. Rebalance the carbon cycle and reduce any impacts of climate change. Each strategy challenges human behaviour and is costly. Some are untested. Others require simple changes to the way people live, such as changing local patterns to drive less, for example, consuming locally produced food, or to reduce waste. The IPCC states that the scale of the challenge is daunting. These actions face barriers related to financing, public perception, and the long-standing dependence of markets and institutions on fossil fuels. Agreements at a global scale are needed, as well as national efforts which impact on people's everyday lives. Adaptation strategies. Water conservation and management. Israel has a range of strategies to manage its limited supplies of fresh water, such as smart irrigation, recycling sewage water for agricultural use, reducing agricultural consumption and importing water in food as virtual water, adopting stringent conservation strategies and managing demand by charging real value prices for water to reflect the cost of supply and ecosystem management. 2. Land use planning and flood risk management. Different strategies can be used to adapt to climate change. They include land use zoning, a technique used for flood management, where development on floodplains is limited to low-impact things like playing fields and parks. This is a low-cost approach to flood management. Infiltration occurs naturally and surface runoff is reduced along with the risk of wider flooding. 3. Resilient agricultural systems. Conservation cropping is growing in use, from the USA to Syria and Iraq. It involves growing crops using a no-tilling approach. It uses fewer fertilisers, retains stubble and grows cover crops. The benefits include increased yields and incomes for farmers, plus improved soil structure, healthier soils, water conservation and erosion control. Fourthly, solar radiation management. This is a form of climate engineering, which aims to reflect solar rays, so to reduce global warming. Examples of techniques include pumping solar aerosols into the upper atmosphere, cloud brightening and space-based reflectors. The advantages include the fact of these techniques that could be deployed relatively quickly, and they offset some of the effect of greenhouse gases. The disadvantages include the uncertainty of how effective they would be, together with ethical, social and political issues surrounding their use, plus they are potentially expensive. Mitigation strategies. Carbon taxation. A carbon tax is a fee or cost paid by users of fossil fuels, which is directly linked to the level of CO2 emissions that fuel produces. It won't guarantee a reduction in the level of CO2 emissions, but the idea is that it sends a message to change to a form of energy which produces fewer emissions. The UK's carbon price floor is a tax on fossil fuels used to generate electricity that came into effect in 2013. Carbon taxation. A carbon tax is a fee or cost paid by the users of fuel emissions, which is directly linked to the level of CO2 emissions that the fuel produces. It won't guarantee a reduction in the level of CO2 emissions, but the idea is that it sends a message to change a form of energy which produces fewer emissions. The UK's carbon price floor is a tax on fossil fuels used to generate electricity that came into effect in 2013. Energy efficiency. A study in 2014 identified Germany as a world leader in energy efficiency. The study ranked the world's 16 major economies that had done the most to increase energy efficiency. Germany's policies included requiring residential and commercial buildings to reduce energy consumption by 25%, loans to renovate older energy-consuming properties, and subsidies to improve efficiencies in manufacturing. Germany's economy has grown, while still increasing its efficiency and reducing the negative environmental impact of energy use. The USA was ranked 13th, having made some progress but was still wasting a lot of energy. Afforestation and reforestation. Canada and Sweden lead on afforestation and reforestation, but South Korea has had a remarkable turnaround. Forest degradation in South Korea accelerated during the Second World War and the Korean War. Illegal logging, the use of firewood and the expansion of slash-and-burn agriculture added to its destruction. The government included forest rehabilitation projects as part of its economic development plans. Between 1961 and 1995, the area of forested land in South Korea rose from 4 to 6.3 million hectares. By 2008, 11 billion trees have been planted. About 2/3 of South Korea is now forested. The benefits include the restoration of degraded environments, the prevention of soil erosion, and the provision of forest sinks and stores of CO2. Renewable switching. Sweden leads the way in switching energy sources from fossil fuels to the use of renewables. Oil has fallen from providing 75% of Sweden's energy in 1970 to 20% today. The benefits of Sweden's move to clean, renewable energy are clear. Although it consumes more energy per capita than many other countries, its carbon emissions are comparatively low. 83% of Sweden's electricity is produced by nuclear and hydroelectric power. Combined heat and power plants produce 10%, mainly powered by biofuels, and around 7% comes from wind power. Carbon capture storage. In 2014, Boundary Dam in Canada's Saskatchewan province became the world's first commercial carbon capture coal-fired power plant. It aims to cut CO2 emissions by 90% by trapping it underground before it can reach the atmosphere. It is a state-owned electricity provider that is expected to reduce greenhouse gas emissions by about 1 million tonnes a year, equivalent to 250,000 cars. Global agreements and national actions. One of the main problems related to climate change is the uncertainty around the rate and scale of the change. Rising global emissions affect all countries, but in different ways. Attempts to agree strategies to tackle climate change are notoriously difficult because most countries try to protect their own interests. The most significant climate agreement to date has been the 2015 Paris Agreement. At the UN's Paris Climate Conference in December 2015, 195 countries accepted the first legally binding global climate deal. It set out an action plan to limit the average global temperature increase to 1.5 degrees above pre-industrial levels, report on the implementation of individual national plans to reduce emissions, strengthen the ability to adapt to and be resilient in dealing with the impacts of climate change, provide adaptation support for developing economies, for developing countries, and continue to support initiatives in developing countries aimed at reducing emissions. The Paris Agreement came into force in November 2016. 96 states, accounting jointly for 66% of the global emissions, ratified the treaty. Actions and attitudes. Achieving agreement about actions to deal with climate change depends on cooperation from many groups. The governments of countries at different levels of development might disagree about the best way to achieve progress. Some fear that curbing emissions universally might hamper economic growth for the developing countries, and also they're being unfairly penalised now, given that the damage has already been done by existing industrialised nations. Governments are wary of losing votes by introducing energy levies or taxes to cut energy consumption. Globalisation has helped TNTs to develop trading advantages and access global markets. Reduced greenhouse gas emissions could increase their manufacturing costs. However, there are benefits in promoting green consumer products. People in countries at risk from rising sea levels view climate change as more of an urgent problem than others. In Australia, one of the world's highest per capita energy consumers, there is growing resistance to policies that will put their coal miners out of work or increasing fuel costs. Some claims about actions that are apparently achieving climate change goals can be deceptive. For example, a fall in CO2 emissions across the EU in 2015 was less to do with changing attitudes and more to do with the fact that the warmer winter led to reduced energy consumption. And that is the end of the carbon cycle and energy security revision unit over here on my channel. I will have a big roundup, kind of like an hour-long video, just saying everything into one video, because I appreciate there's a lot of different things. So look out for that, subscribe down below so that you don't miss it, and I will see you same time, same place next week for the next topic in the revision series. I do apologise about the rain and the cockerel and whatever noise you can hear. It's not the easiest place to film in the world, but I hope you enjoyed, and I will see you soon. Bye guys, good luck.